Now let's take a look into two example problems, one dealing with a circuit with resistors in parallel and one with the resistors in series. So let's compute the current I for the two circuit elements shown below. First circuit, imagine that we have 12 volts on one side, 0 volts at the other. We can connect a circuit with a battery here. We can look and say, what is the current traveling through the wires, through the resistors? We can see that we have a resistor of 3 ohms followed by another resistor of 3 ohms. And since they are one after another, they're in series. So the change in voltage from A to B, 12 volt change, is equal to I times R total, our equivalent resistance. Or we can rearrange it saying that the current through this wire is equal to the voltage drop across the resistors divided by the equivalent resistance. As we said, the voltage drop is 12 volts, and the resistor, the equivalent resistance is given by 3 ohms plus 3 ohms. We're adding our resistors in series, will give us a total of 6 ohms. So the current is equal to 12 volts divided by 6 ohms, which would give us 2 amps. Now let's look at the same resistors, but this time in parallel. Again, we start with 12 volts on both sides, or on one side, and drops to 0 volts on the other. And we have 3 ohm resistor and a 3 ohm resistor, this time in parallel. So our equivalent resistance, 1 over the resistance, is equal to 1 over the first resistor plus 1 over the second resistor, or 1 over 3 ohms plus 1 over 3 ohms raised to the -1 will give us our equivalent resistance. This turns out to be 3/2 of an ohm. So again, our current is equal to our 12 volt drop divided by 3/2 ohms, which gives us 8 amps. So if we actually compare the two, we can see that the series, we only have 2 amps, and if we go through parallel, because we have multiple paths, we have a higher current, we get an 8 amps through the parallel.